Hello students, today I am going to explain the topic electric field at the equatorial point of electric dipole. Students, as we have already read what is the electric field at the axial point of electric dipole, we already learned about it is minus q, it is plus q, it is the arrangement of electric dipoles that are separated by a distance r. It is the center, and we have already calculated electric field at the axis of this dipole. It is the axis, and here is the point P. We already find electric field at this point. Now we have to calculate the electric field at the equatorial point. Where will be the equatorial point? Equatorial point will be at the midpoint and vertical position and perpendicular position of the electric dipole. Here, it is the point, suppose. It is the perpendicular vertical position. Okay, students, it is the point P. We have to calculate the electric field at this point. So as we know that the electric field due to minus q charge. So when we connect this, then here we can see that the direction of the electric field towards charge this side. And when we connect to this point, then due to this plus q charge, the direction of the electric field towards this. This is E plus q, and this is E minus q. Okay, students. Now here we can see that we assumed it is point B, and it is point P. The direction of electric field at point P due to Q charge equal to this along BP. Along BP. And the direction of electric field due to charge minus Q along PA. Along PA. Okay, students, it is clear. And after this, we have seen that the magnitude of plus Q, magnitude of this charge and this charge are same. So magnitude of E plus Q and magnitude of E minus Q would also be same. So then we have to calculate the resultant electric field between them. So at the bisecting angle position, same angle, it is the resultant E equatorial. Then it is theta, same angle, theta. And here we can see that this line and this line are parallel lines, and it is slant line. So they are adjacent angles, means this angle and this angle will be same theta. And if this is theta, then this will also be theta, because it is bisecting line. Bisecting line of this total angle. Okay, students. So I have cleared this concept, how to calculate and uh, how to find the resultant electric field between E plus Q and E minus Q. Okay, students, this is the figure you can draw. Okay, students. Students, from here and here it is A, and here it is also A. Okay, students. And also we can see that if we draw this part, only this part, it is P, it is R, it is A. And if this is angle theta, then what will be value of PA? It is a right angle triangle. So here we can see that it is hypotenuse. Then hypotenuse equal to PA square equal to PR square plus AR square. Then PA, as we know that here its value is A. This is A and this is R. Here we let this point is O. This point is O. Okay, students. So this point is O, and this value is R. Here we have drawn dot dot dot, and this is straight line by placing pen here. So what is the value of PA? Then PA square equal to R square plus A square by Pythagoras theorem. It is hypotenuse square equal to perpendicular square plus base square. Okay, students. So PA equal to R square plus A square means R square plus A square power 1 by 2. Okay, students. Please note down. Please note down. Here we can see that it is electric field E plus Q due to point charge plus Q, and this is electric field due to minus point charge minus Q. Okay, students, here we can see that magnitude of this and this charge are same. So magnitude of this value and this value would also be same. Here we can see that if we draw P plus Q and it is E minus Q. Okay, students, it is E minus Q. E plus Q and it is E minus Q. Then E plus Q. Its base component. If we draw this base component, its base component is this. And its base component is this. And its normal component is this. Normal component is this. Okay, students. Its base component is this and its normal component is this. Okay, students. And if we draw this line, then its base component is its base component is its base component is this, and its normal component is this. Normal component is this. Okay, students. The normal component is this and base component is this here. So we draw the here. Here we can see that the base component of E plus Q and base component of E minus Q have the same direction. Have the same direction. It is base component. And students, we can clearly see that the normal component of E plus Q towards upside and normal component of E minus Q towards downside. Okay, students. So here, please see clearly the base components of both electric fields will be add up, and the normal component of both electric fields will be in opposite direction. In opposite direction. So due to their magnitudes are same, this component and then this component will cancel out each other. Okay, students. Normal components of E plus Q and E minus Q both will cancel each other. Only the base components will get added up, and it would be the E equatorial resultant. It would be E equatorial resultant. Okay, students. So here now I am going to derive the expression for electric field at the equatorial point of electric dipole. Okay, students, please note down. So, students, it is the figure. Here we have to find the electric field at the equatorial point of electric dipole. It is the dipole arrangement minus Q and plus Q separated by a distance 2a. It is A and A. So it is 2a. It is the direction of electric dipole moment P, and it is the point O. It is the center point of electric dipole. From here, we can draw a line vertically and perpendicularly, and uh, that touches which point P. Here it is the point P. Here we have to calculate the electric field that is at the position of equatorial point, equatorial line. That is this point is available on the equatorial line. Here we can see clearly that due to plus Q charge, electric field is E plus Q, as I have already cleared here. Okay, students, and due to this minus Q, the electric field E minus Q, E minus Q. Okay, students, as we have seen that if this is E plus Q and E minus Q both have same magnitude, so the resultant electric field E equatorial, Direction would be here. Direction would be here. Because as we have seen here, I have drawn that the vertical components of both electric field will cancel out each other and only base component will get add up. So this is result. This is result. As we have seen that it is the angle theta and this is perpendicular line, sorry, parallel line, anti-parallel. If it is theta, then it is also theta, and if this is theta, then this is also theta, because this line is bisecting. Because this line is bisecting. So if this is theta, then it is also theta. Okay, students. So this is also theta. Okay, students. Now, as we know that electric field formula equal to kq upon r square with magnitude. We will write with magnitude. But we will here not take into account the sign plus or minus q. Okay, student, we will only show here the directions. Okay, students, we will show only directions. Okay, now electric field at the point P. At the point P, due to charge plus Q, EQ equal to K Q upon R square. Here we can see that we have already find the distance here. If it is a plus q and we have to calculate the electric field point P at point P, then it is the distance. So what will be the value of the distance? R plus a square power 1 by 2. R square plus a square power 1 by 2. Okay, students, and the direction along BP. Direction along BP. Directed along BP. Okay, students, and now same E minus Q, electric field due to electric field due to minus Q at point P. So, students, E minus Q equal to K Q upon R square plus A square power 1 by 2. Here we can see that it takes the same distance, E minus Q, same distance. So we have take this distance R square plus A square power 1 by 2. Okay, students, directed along, what is the direction? This direction, PA. PA. Okay, students, please note down this. Now, students, here we can see that it is the electric field E plus Q and it is E minus Q. Here we can see that as we have already see that the normal component of this and this will cancel out each other. Only base component will be added up. Okay, students. So base component of this and base component of this we will take. So What is the base component? E plus q, it is the base component. It is the base component and its value is E plus q cos theta. E plus q multiply cos theta. As we know, say, as we have already read from class 9, 10th, if we have to find a base component of a triangle, then multiply by cos theta with hypotenuse. If hypotenuse is E plus Q, then base component is E plus Q cos theta. E plus Q cos theta. Okay, students, here we can see that E plus Q equal to E minus Q. Here E plus Q equal to E minus Q. E minus Q. So E plus Q. So E plus Q cos theta equal to E minus Q cos theta. Okay, students, this value we we have to take only E plus Q cos theta of this, and from here E minus Q cos theta from here. Okay, students, I hope you have noted down. Then uh, so E plus Q cos theta equal to, what is the value? KQ upon r square plus a square power 1 by 2 multiply cos theta. Please note down, students. I'm going to clear this. So students, if E plus cos theta equal to this value will be same for E minus Q cos theta. So E plus Q cos theta equal to E minus Q cos theta equal to KQ upon r square plus a square power 1 by 2 cos theta. Okay, students. So now we are going to add up the base components of electric field. Okay, students. So E plus Q cos theta plus A minus Q cos theta equal to Q KQ upon R square plus A square cos theta plus KQ upon R square plus A square cos theta. Okay, students. Here we can see that this value is equivalent to resultant of E equatorial, and we have clearly seen that the direction of electric dipole moment is towards this, and the direction of E equatorial is this opposite direction. It is the opposite direction. So if we take with direction, then we can put then we can put minus. It indicates the opposite direction of dipole moment. Here we have put down minus because minus indicates opposite direction of this dipole moment. So we have taken it is the unit vector that indicates the direction of the dipole moment. It is the unit vector P that indicates the direction of the dipole moment, and it is the direction of dipole moment, and it is minus means this value, this total value indicates the direction opposite to the dipole moment. Okay, students. So further solving, r square plus a square to the power 1 by 2 to the power 1 by 2 to the power 1 by 2. Then its value is 2k q cos theta. It is the direction, and here minus. Okay, students, please note down this. Please note down. I am going to clear this. Now, students, we have to calculate the value of cos theta. We have to calculate the value of cos theta. We can see here, if we apply in this triangle AOP, if we apply this triangle OAP, then cos theta equal to, as we know that cos theta equal to base upon hypotenuse. Base upon hypotenuse. Okay, students. So cos theta equal to, what is base value? Base value is A. From here, it is A, and hypotenuse this means it this value. So A upon r square plus a square power 1 by 2. It is the cos theta value. This value is cos theta. Okay, students. This value is cos theta. So I'm going to clear this. This value write down for further solving. Minus 2kq cos theta upon r square plus a square power 1 by 2. Okay, students. Then put the value of cos theta from here to here. Equatorial equal to minus 2kq upon r square plus a square power 1 by 2. What is the value of cos theta? This means a upon r square plus a square power 1 by 2, and it is unit vector. Okay, students. So equal to minus 2k cube upon, and this is a upon, and multiply r square plus a square 1 by 2 and 1 by 2 means what is the value of power? 1 by 2 and 1 by 2 plus 1 by 2 means here we have done some mistake. Students, here this when multiply 1 by 2, as we know that x to the power 5 multiply to the power 5 equal to x to the power 10. So when we will add this power 1 by 2 plus 1 by 2 means 1 power. Okay students. Now minus 2k, and we know that 2q to aq multiply k upon r square plus a square equal to its value dipole moment, so minus p minus kp upon r square plus a square. Okay students, it is the value of electric field at the equatorial point. But if this distance is much greater than this distance, if r is greater than a, then neglecting a, then neglecting a, then neglecting a, if we neglect a, if we neglect a, then what is the value of minus k p upon r square, minus kp upon r square. Okay students, please note down. So student, it is the value of electric field at the equatorial point, kp upon r square. Okay student, it is the value of kp upon r square equatorial, and minus direction shows that it is opposite to the direction of dipole moment. It is the opposite to the direction of the dipole moment. Okay students, if you want to see or learn physics, then you can subscribe my channel for upcoming class 12th board exams physics, and for Neet and IIT exams. Okay students, bye bye. Students, in this video I have done some mistake because as we know that it is the distance r square plus a square power 1 by 2. It is only distance and we have already know that electric field equal to kq upon r square. Means we have to take the square of the distance. We have to take square of the distance. If the distance is r square plus a square की power 1 by 2, then we have to take square of this. So we have seen that this, it is the distance, so we have to take the square. Okay, students? So we have taken square of this. In magnitude both are equal. In magnitude both are equal, and as we have seen that only uh, base component will add and normal component will cancel each out. Then we have take E plus Q cos theta equal to E minus Q cos theta equal to KQ upon R square plus A square power 1 by 2 square cos theta. Okay, students, and we have seen that cos theta equal to A upon this value, theta equal to this upon this, A upon R square plus A square power 1 by 2 base upon hypotenuse, base upon hypotenuse. Okay, students, so then E plus Q cos theta plus E minus Q cos theta equal to Kp upon R square plus A square power 1 by 2. Here we can see that if we square then cancel, plus cos theta plus k q upon r square plus a square cos theta. And what is the direction? Here we can see that only base component add up and the direction is opposite to the direction of dipole moment. So we have taken here minus sign. We have taken here minus sign. Okay, students, it is the unit vector that shows the direction of the dipole moment, and we have taken here the minus, means its direction is opposite to the direction of the dipole moment. Okay, students, so equal to minus 2 kq cos theta upon r square plus a square, unit vector. Okay, students, so put the value minus 2 k q upon r square plus a square multiply, what is the value of cos theta? This, a upon r square plus a square power 1 by 2, and it is unit vector. Okay, students, now I am going to clear this. Please see clearly. So further solving, minus 2 a q k upon solving this r square plus a square power 1 plus 1 by 2 equal to 1. This value is P, dipole moment, K upon I square plus A square power 3 by 2. Okay students, here it is the formula for equatorial electric field. Okay students, E equatorial equal to. Now if this distance is much greater than this distance, if R is greater than A, then E equatorial equal to minus Kp upon, neglect this value, neglecting I square power 3 by 2 vector equal to minus Kp upon R cube. It is the formula when this distance is much greater than this distance. Okay students, E equatorial equal to minus Kp upon R cube, and it is the unit vector that indicates the direction of dipole moment, and here minus shows that the direction of E equatorial will be opposite to the direction of dipole moment. Okay students, I have taken, sorry, I had taken some mistakes, so I'm going to add this part. So I'm going to add this part with my video in which I have explained electric field at the equatorial position. So I have corrected and this part I have added. Please see this. Okay students, bye bye.